Hello everyone and welcome back to Tesla Harmonics. Today I want to continue looking at Module 26306-23, Distribution Equipment in the NCCER 11th edition. This will be Section 3.00, Testing and Maintaining Switchgear. Testing and maintaining switchgear. Switchgear requires regular testing and maintenance to ensure mechanical and electrical integrity. Installation resistance tests are taken on each bus section, phase to phase and phase to ground for 1 minute. Test values depend on whether an acceptance test or a maintenance test is performed. Test guidelines. A thermographic survey is used to check switches, busways, open switches, switchgear, cable and bus connections, and circuit breakers. Metal enclosed switchgears and switchboards. Periodic visual and mechanical inspection should be performed on metal enclosed switchgear and switchboards, low voltage cables, medium voltage cables, metal enclosed busways, and metering and instrumentation. Warning: you must be qualified and authorized to perform these tests. Ensure there is no voltage present prior to testing. Ground faults. Conventional breakers may not detect high arcing, low-level ground faults. NEC Section 230.95 addresses ground fault protection of equipment. Methods for detecting ground faults include ground return, residual, and zero sequence methods. Sensing operation. Under normal conditions, the current from all phases and neutral conductors add up to zero. When any ground fault occurs, the sensor produces a signal. A time delay is used to eliminate nuisance trips, and a ground fault relay is a high reliability device due to its solid-state construction. The CT-style sensor should be mounted so that all phase and neutral, if present, conductors pass through the core window once. Maintain at least 2 inches of clearance from the nearest bus bar or cable. Relay mounting. Ground fault relays should be mounted in a vertical position with the terminal block at the lower end. Connections should be made in accordance with the manufacturer's wiring diagrams. A ground fault relay trip setting will depend on its application. Ground fault system test. NEC Section 230.95C outlines required electrical tests for ground fault systems. System neutral insulation resistance should be above 100 ohms. Maximum pickup setting of the ground fault protection should be 1200 amps, and the maximum time delay shall be 1 second for ground fault currents equal to or greater than 3000 amps. Relay pickup current should be within 10% of the manufacturer's calibration marks or fixed setting. Relay timing should be in accordance with the manufacturer's published time current characteristics. There are no trade terms for this session, but there are some review questions. The typical installation resistance of equipment rated for 480 volts is 10 megaohms, 50 megaohms, 100 megaohms, or 1000 megaohms. It's going to be C, 100 megaohms. A typical overpotential test voltage for a used piece of equipment with a nominal voltage class of 600 volts is 600 volts DC, 1000 volts DC, 1500 volts DC, or 2000 volts DC. That's going to be D, 2000 volts DC. A ground fault relay should be mounted in an enclosure in a vertical position with the terminal block at the lower end, in a horizontal position with the terminal block at the lower end, in a vertical position with the terminal block at the upper end, or in a horizontal position with the terminal block at the upper end. That's going to be A, in a vertical position with the terminal block at the lower end. Alright everyone, that was it for that session. Next session will be review for the module testing. We'll do that in the classroom, and I'll see you over there.